Bom dia. Guten Morgen. Nobody looking up? So, thanks for coming back. I hope everybody had a pleasant evening yesterday. We have another long day planned today, but I think hopefully lots of interesting things to talk about, and I already know that there were some plans made yesterday that are good, so we'll keep that up today. We'll have some breakout groups in addition to some talks. So we wanted to start out, yesterday with Luana, we were, emphasizing not only ATTO's work, but how we fit into the larger picture. And so we continue that today with first, I guess, Christopher and then Luis Machado will talk about aircraft campaigns and Café Brazil. And Christopher, please.
And now? Good. So good morning, bom dia, and guten Morgen. I'm actually not supposed to stand here because this was meant to be the talk of Joost Lelyveld. Oh, I have to stand here. Who's the director in Mainz, so he's the German PI of the Café Brazil aircraft campaign, but he's on its way to South Korea, so we were asked, so we is Luis Machado and myself, to help out, so that's why we will give this little not very formal presentation on the aircraft campaign, and this is meant to be not the final word, but rather a Kickstarter. So ideally, if we do a good job, this is kind of fostering lots of discussions on the various scientific connections between the HALO activities, the aircraft activities, and various other activities you will see later. So CAFE, that's an acronym standing for Chemistry of the Atmosphere Field Experiment. This time in Brazil. There have been some before, as you will see on some of the later slides. And this is our brief outline. So the idea is to show you what's going to happen, so kind of when and where and how the aircraft campaign will take place, just some key facts. We will show you essentially what to aim for, so what's the scientific objectives of the campaign, the research focus. We want to briefly touch what to expect, so this is meant to kind of speak about the atmospheric conditions. We are probably kind of probing, essentially. This is one of the aspects where ATTO comes in, because that's a very precious scientific context for the aircraft campaign, as we understand kind of the system, at least at the ground at ATTO, pretty well. And then for the last point, what else? I will hand over to Luis, and Luis will present some other activities beyond the aircraft and beyond ATTO that are taking place. And all of that, I think, is a pretty unique combination of experiments and campaigns where we should make use of. So the idea would be also to start discussions to see where the scientific synergies are and to get most of research out of it. And as we're not using the whole 90 minutes here, don't be afraid. There will be hopefully soon here for discussions here in the plenary and then later in the breakout session. So that's our tool, that's HALO. HALO stands for High Altitude Long Range Research Aircraft. It's not the only, but maybe the most fancy German aircraft. There are many more around, but that's the one where also the Max Planck Society is kind of deeply involved. And this is a selection, that's not all, but a selection of previous HALO campaigns all over the world, so essentially the more or less related ones. The last one in Brazil was Acredicon Chuva in 2014. This was the last and so far the only HALO campaign here, also operated from Manaus. At that time, this was an aerosol cloud microphysics campaign, so the payload is limited, so there's always kind of a scientific focus this time. Or at that time, 2014, they tried to understand kind of the gradient between the natural aerosols, the biomass burning smoke, and the influence on cloud microphysics, cloud dynamics, precipitation formation as an essential piece of the hydrological cycle. And all the other campaigns here are more chemistry-based campaigns, as will be also Café Brazil. So the payload of HALO will be there focused on gas phase chemistry and the interface to the chemistry of the aerosol particles. And the focus will be to understand essentially the interaction and how the gas phase chemistry also fosters the formation of new particles. You see here, so there's also two other CAFE campaigns. This also kind of indicates that there have been previous experiments with a similar payload. In fact, the payload is not much different from what has been flown here in the outflow of Africa. and what has been flown here over Europe 2 years ago. There's some new instruments, some upgrades, but there is previous experience that we built on essentially. And just as a key, or as a side aspect, you see here this Café Europe campaign. This was actually meant to be Café Brazil in the wet season 2020, and then COVID hit us and everything got delayed. Luckily not cancelled, but at that point, which was obviously pretty chaotic and so on, Harlow was essentially ready to go, equipped. And then in a pretty spontaneous initiative, Harlow was used to fly over Europe, because during the core time of the lockdown, with all activities being frozen, essentially, this was also unique in itself. So we had this very spontaneous campaign with the Café Brazil instrumentation over Europe to probe the relatively clean atmosphere. That's why it has this second name, Blue Sky. So this time again, Brazil, again operated from Manaus. And that's a preliminary quick look of the flight planning, essentially. I'm actually not quite sure if the final word is spoken there, but there will be certain flight corridors in various directions, essentially. With the long range of the aircraft, you can cover the entire Amazon basin. And then depending on atmospheric conditions, depending on the scientific key questions, there will be flights to the northwest, where it's typically kind of the cleanest places or conditions we can probe. There will be flights to the south, where we'll still probe some influence of biomass burning. There will be certainly flights to the northeast, which is the ATTO footprint area, so that's particularly interesting for us. And then kind of in the east-west direction, if we get some long-range transport from Africa, dust, for example, this will be also then one aspect to probe how this, the plumes being transported are being aged and transported into South America. And I think I heard the plan is that for most or maybe all flights, the plan is to go from Manaus Airport first to ATTO, to have kind of this link between the ground measurements and the ATTO measurements, and then go on in the various directions, which hasn't been quite so the case for Acridicons. So there we had one flight to ATTO, and this time we are hoping that we get more kind of these connection points, which would be really precious to link the ground-based measurements and then the Harlow profiling. So this would be the key objectives. So the first one would be to look really in detail in the gas phase chemistry to understand the influence of this enormous amount of VOCs being emitted from the vegetation in the atmosphere in relation to the oxidation chemistry and especially the radical chemistry. And here one goal is to constrain the mechanisms that are responsible for the recycling of OH. So that's kind of probably the most important radical in the atmosphere, also often referred to as the detergent of the atmosphere, and kickstarts a lot of these reaction change kind of in the degeneration of a variety of compounds. The second one, this is then indeed the interface between the gas phase and the particle phase. And this is touching some pretty fundamental open questions we still have, because to some degree, we still don't have a good answer where the particles are actually coming from at ATTO. Part of them. There are some sources we understand quite well, but essentially the stuff that's formed in the atmosphere, so there's still a bunch of open questions. And especially for this question, the combination of the ATTO ground-based measurements and the aircraft in the air will be pretty unique. Number 3 is, well, semi-obvious. I mean, we will obviously kind of probe different conditions, and this will help us a lot to understand further the anthropogenic influence, so kind of ranging from the pristine northwest. Hopefully it gets pretty pristine to the southeast, kind of with the biomass burning. The Manaus plume will play a role. And there's also a chance that we go over the Atlantic for some flights. So we will have the contrast between the Amazon, the green ocean, and the Atlantic as the blue ocean. So that's kind of the spectrum of conditions we are hopefully then going to probe. And all of that in the end then kind of will help us to improve our understanding in terms of mechanisms and also to improve atmospheric chemistry models and climate models. That's the payload, so I'm not going into too much detail here, just to give you a brief overview. So there is some basic meteorological parameters being measured. Actually, the first one is always on board, so that's pretty accurate, temperature, humidity, and so on measurements of the aircraft itself. Then there will be water mixing ratio, there will be radiation measurements, there will be a broad spectrum of pretty reactive trace gases here. Here's some more. So that's the gas phase side of things. Then we look in the abundance and selected properties of the aerosol particles, and of particular importance is kind of the link. That's what the activities from Frankfurt are doing. So the interface between gas phase and particle phase is fuzzy. So at some nanometers onwards, it starts to become a particle. So kind of the The initial state are these clusters that are formed, so that's kind of the initial state of new particles being formed. And with a mass spectrometer that's been flown from Frankfurt, we look exactly kind of in this moment of birth of the new particles, and then in the continuous growth. In fact, to relate this to ATTO, there will be similar instruments also at ATTO. Louis will mention this as well, so this is one of the various links kind of bringing both activities together. So this is just showing you as globally, as a function of latitude, the flux of different classes of volatile organic compounds. And you see, so we are here, you see that in the southern hemisphere there's this huge peak of biogenic VOCs due to the enormous vegetation, especially the rainforest we have, plus of course also some contribution of anthropogenic emissions and biomass burning. But the Amazon is certainly a hotspot essentially if you want to understand VOC atmospheric chemistry. Not quite sure what Jos was intending to say here, but I would say the following. So the OH recycling is a focal point. And we know from measurements that this recycling is taking place, although the models don't really capture it yet. I think that's meant kind of by this scheme here. And this is, of course, one of their key interests in the gas phase groups to improve the mechanisms in the models to account for the various mechanisms in the atmosphere. And that's then also without detail here. That's kind of some of the reaction changed, a bit more generalized of the isoprene chemistry. So isoprene is one of the main VOCs emitted from the rainforest. OH, as mentioned, is one of the key radicals, kind of starting this and a bunch of other reactions, and then it goes in various branches with lots of intermediates. So we are going to measure isoprene, OH, and then selected key species in all this chemical change. And by constraining those, this will likely help to get a better idea of the overall picture. In order to improve the models. So this is global match, that's a model output, that's the Mainz isoprene mechanism. That's kind of a module for the global models they are running in Mainz and beyond. And this is different versions, you see kind of generation 1 and 3. So I think this is meant to show that in the beginning the initial versions didn't do a particularly good job in kind of accounting for the isoprene recirculation. You see isoprene here is pretty low, and then at least some mechanisms have been improved here, so there's a certain isoprene level, but it seems there's further improvement needed, and Haluka field will be kind of a key campaign here to constrain this particular aspect in the chemistry models and beyond. This is another link to the ATTO activities. This is work from the last years from the team of Jonathan Williams. They actually measured the OH reactivity. Here in contrast to Beijing, but I will just focus on the Amazon. So you see the diurnal cycle kind of the OH reactivity. That's the total essentially, and the isoprene accounts for a significant fraction, though there is kind of an even larger fraction of the reactivity that's probably due to reaction products of the isoprene reaction change or other VOCs, terpenes, sesquiterpenes, and so on. As there are still also several open questions what actually this VOC mixture is exactly that's emitted by the rainforest, also in relation to the conditions. So that's another link to ATTO then. And now we switch from gas phase to particle phase. This is from the ATTO overview paper. You see kind of 1 year of measurements with the composition of the submicron aerosols. And it's pretty obvious that most of the particle mass indeed is organic. That's something we know, but here it comes out really nicely essentially. There's inorganic fractions, but most indeed is organic compounds to a large extent formed in the atmosphere. And that's both. So we talked about the formation of new particles that we want to understand, and then, but also the continuous growth essentially that makes from the clusters and nanoparticles then particles that are big enough to act as cloud nuclei essentially that then affect the cloud dynamics. So we want to understand the gas phase chemistry and also how this translates then in the chemistry and composition of the organic particles. So this puts things in a little bit a bigger picture. So I want to focus first on the right side. This is meant to be kind of the aerosol life cycle at ATTO, and in principle, you can put it relatively easy. So if you want to understand what's out there, what's the particles we measured at ATTO, you can break it down essentially to 3 classes only. The first one would be what's emitted from the rainforest. That's what we refer to as primary emissions. This is fragments of leaves, insects, that's fungal spores, bacteria, all sorts of stuff that's emitted from the vegetation in the atmosphere. Sounds easy, of course, this mixture is pretty wild and we don't understand the details, but that's one class of them. A second class would be all the particles coming from somewhere else. This could be kind of the smoke from the fires in the southern Amazon. This could be long-range transport from dust and smoke from Africa and so on. So everything that comes from outside into the scene. And then class 3, that's then the particles in contrast to the primary particles, directly emitted, or the particles being formed in the atmosphere. And these particles can in principle be formed kind of close to the ground. That's a phenomenon that we see worldwide in various locations, kind of this famous banana plots, clusters being formed, particles grow into a cloud-relevant size range, so it's this very characteristic banana-like shape in the plots kind of we generate. At ATTO it looks different, so that's why this has been a question for decades, where actually the particles are coming from in the Amazon. And there have been more and more indications recently at least that in the upper troposphere, so kind of beyond 7-8 kilometers, there is kind of nucleation taking place. So that's also what we saw in Acridicon. Not quite with the right instrumentation, but it was pretty obvious that there is this huge pool of particles. And then these particles at least partly wash down in the course of convection and are injected in the boundary layer. So we see them at ATTO. But the question is, first of all, so what's going up here? So what's the chemistry going on? What's the kind of the favored conditions for these particles being formed and how they are coming down? And is this accounting for kind of all secondary particles, or is there indeed also some further similar processes in the middle or lower troposphere going on? It's actually something Lewis is currently investigating in quite some detail. And just few profiles to be shown here. So this is CN, that's condensation nuclei, means all particles being measured, so entire size range with 2 profiles. So the red one, this is from Acridicon, dry season 2014. The green one is from a wet season from the early 2000s. You see that in the boundary layer, you see this belly, that's the pollution belly, that's the smoke and so on, there's a clear difference. But if you go higher, 5 kilometers and beyond, essentially, they look quite similar. Which could indicate that the processes are there actually all over the seasons, essentially, maybe different, but this pool of particles, so all these tiny particles here, that's the ultrafine fraction, this 100%, you see that the higher you go, the more there is small particles, so this pool essentially contributes at least to some extent to the boundary layer particle population. So having ATTO here, and then HALO flying around, essentially, we can stitch both projects, and this will hopefully likely significantly improve our understanding of these processes here. Now, since we have the right instrumentation on board, so kind of chemistry, I think we can answer some of these open questions. Then briefly on nucleation, also not in much detail, so this is a scheme which relates to the growth of the particles. This is quite freshly born, very small particles that grow from few nanometers to 100 nanometers, so here we are getting in the range that's relevant for clouds, that can kind of nucleate cloud droplets. This is related then to the processes, so the gas phase particle interface, new particles being formed. The particles grow from condensation, maybe also to some extent water phase chemistry, and then when they reach this range, they have a climate relevance. And then this is now kind of bringing the chemistry into the game. So what has been known is that, for example, sulfuric acid, kind of based on the oxidation of SO2, very efficiently nucleates particles. This happens, for example, in more polluted regions where lots of sulfates are around. So sulfuric acid is a key player here in the onset, kind of initiates the formation of the particles, and as they grow, there can be amines and also organics and so on contribute to the growth. And a few years ago, it has been shown that also purely biogenic VOCs can make the nucleation themselves without sulfuric acid. That's relevant for ATTO because the SO2 levels are typically pretty low. So with ATTO, we are most of the time not here, but up there. But this can also nucleate, essentially, and then the growth is driven essentially by the organics being condensed. For example, this extremely low volatile organic compounds, L is just low, semi-volatile, so there's this spectrum of volatilities. And part of that condenses on the particles and drives their growth. So and then a few slides still on which conditions to be expect. So it was meant to be a wet season campaign originally, but due to the very tight HALO schedule, now it became a transition period campaign. So typically wet season, that's February to May, kind of when it's cleanest, when we have most rain and so on. Then we transition into the dry season, June, July, dry season, August to November, then it's most polluted, least rain. So we're now measuring, so that's the red box here, in December and January. So when we transition from the dry season back in the wet season, this could be actually quite interesting because this time of the year is pretty variable. So there's a good chance that we probe a broad spectrum of very different conditions, reaching hopefully from pristine episodes all the way to polluted conditions. And if we are lucky, kind of towards January, there's also a chance that we get Saharan dust, which would be another interesting facet, of course, in terms of conditions. And then briefly speaking about Africa, so we have a pretty significant source of aerosols in front of our door, so that's partly kind of not really appreciated, but it's not just the ATTO footprint and the conditions here. There's a lot of stuff coming over the Atlantic, dust and also smoke in the wet season here from the fires in the Sahel belt, and also in the dry season from southern Africa. So kind of the interplay of the conditions in the Amazon or in South America in a wider sense, but also in Africa, excuse me, define essentially the conditions we are going to probe in this time of the year. And as I said, it's the onset of the dust season, so there's a good chance that we also probe some dust. And then finally, speaking about pristine conditions, so strictly spoken, the atmosphere is nowhere on the world pristine anymore, because at least the greenhouse gases are higher than for the last millions of years. So at least in this sense, kind of pristine is over. But if you talk about the reactive species and the aerosols, there's at least states where we approximate this state in the sense of that pollution is so low that it's mostly kind of the natural processes dominating. And this is based on ATTO data a few years ago, where we try to define some filters kind of to see when and to what extent we have pristine conditions at ATTO. This is here based on our pollution markers, black carbon and carbon monoxide. So in the sense that if carbon monoxide is below the background in the Atlantic region and black carbon is below the detection limit of the instrumentation, we cannot kind of detect the influence of any combustion. And you see that this is distributed essentially at ATTO here from March to May, so that's the window where there's a high chance to have really clean conditions. We are slightly outside, so again the red box is Harlow, but well, there's a certain chance that we probe some episodes, but at least there's a quite good chance that we get clean, maybe not quite pristine, but clean conditions, so again, I guess we will get a broad spectrum of interesting conditions. There would be more to say, but I stop here. With that, I would then hand over to Louis, and we then change the presentations, and Louis will show you a little bit more of related activities along these lines.
Would you like to have a question altogether, or maybe you can do all together? So the slides will be okay. So I will talk more about these complementary field campaigns that's going to happen during the cafe. That's very important, this synergy of different field campaigns, because you cannot address all the scientific questions only in the airplane, because the airplane has limitation of instrumentations. As for acridicon, chuva was more microphysics, cloud and chemics, and this one has all these scientific questions that was presented by Christoph. That is very straight in the understanding of these outflows, the gas and particles clusterization to form, the gas clusterization to form particles. And so it's very important that's complementary field campaigns, because can add information to really figure out all the scientific questions that you have that cannot be addressed only by the airplane. So this is a table. I figure out that the times, I didn't update the time, so forgot the time because some are not correct. But you have the Halo Cafe, but you also have the UAV. It's a UAV campaign that you're gonna happen in ATTO. I will give more details. That's intended to measure aerosols and ozone profiles. You also have radiosondes. That's radiosonde you'll be able to give information about the cloud wind temperature profile, instability, there is ozone. We didn't. We was not able to have ozone sonde. We really would like to have, but was not possible. but this will be a regular radiosonde. There is this aerosol nucleation that is the group from Hangzhou that's intended to measure the particle, because the normal instrumentation in ATTO measure from 10 nanometers. This one you measure from, you measure from 2 nanometers, 1 nanometers, and so it will be very important, and you'll be installed, and we hope that you be ready for CAFE. I'm not sure, still not sure. There is the Campina site that has a different remote sense data from cloud atmospheric information that you give more details to. That is a continual measure. There is the ROLI, it's the elevator that Christoph is in charge. The mini float, that is the boat that you cruise to up the rivers to São Gabriel da Cachoeira. There was the Cloud Roots, that was a field campaign, was already mentioned, that was the leadership of Giorgio Villa, that get very interesting information. We had more than 12 radio sondes per day sometimes. We have radio sondes in the camp, in the Campina, so you have a lot of different information, but the scintillometers was left there, and so you'll be possible to get flux information. And the weather radar that you are carrying here, so I will give you more details about all these activities that are going to happen during the CAFE. So this is just a picture of all these parallel campaigns, but I will more stress about those that I don't have specific information. This, oh, sorry, I couldn't leave here. So this is the scintillometers that Cloud Root installed at 80 meters in the ATTO tower. And it's measured the flux. But what's interesting, that's this instrumentation that's not capture the flux in a specific point, because that is from ATTO tower, and the receptor is the instant tower. So you have a long pixels of flux, like a model pixels, where you can get this flux. And this instrumentation, it's running in ATTO, and you up to the end of CAFE. And this data will be very amazing to be compared with the instrumentation in the tower, as well, to figure this large footprint of flux. The robo, I also don't have a specific slide for that, so that is the robo that Christoph was last week in ATTO installed, and Sebastian, you install the instrumentation next week, so you'll be running and go up and down, and you'll be able to answer several questions. One is, I have in my head that need to be solved. That is the long inlet in 350 meters that you cannot really trust in the small particles concentration, because you can lose and coagulation. So you'll be prove and understand the concept of the particles concentration 350, the smaller one, and in 80. So it's just one of the experimentation in this hobo lift. And so I'll give more details here in the others. So this is the Campina site. For those does not know very well, Rachel, in the afternoon, you will stress much more the details about Campina site. But there is this an old picture. This tower was moved to a much better place that will represent the Campina vegetation. Denise is going to install the instrumentation before the campaign, so you're going to have the flux for Campina. And then in Campina, we have this cloud radar that gives information about the first droplets that is creating the cloud, giving the moment that convection starts, shallow clouds. So you can have an approach of several scientific questions as how is how new particles is related to the cloud dropper spectrum, the formation of shallow clouds, the convection deep to shallow to deep convection. You have the radar wind profiles that gives the vertical profile. The vertical profile, it's something, key parameters to answer. One of these questions is the downdraft, updraft, how to bring particles from the upper level and how it's going to bring these VOCs to the upper level. So all these chemistry that is involved in the scientific questions of the cafe. So it's several instrumentation as well, the electric field that we are having new results. Gabriela, you present a poster this afternoon, show the first ideas using this instrumentation. The radar wind profile, we have 1 year of data, but you have already a paper published using this data, and more 3 papers using this information. Are very rich information. And that will be continued doing in CAFE, and I'm sure that this will be very important for the CAFE and to help CAFE answer the scientific questions. This is the weather radar. This is a couple days ago, and the radar was in INPE, in São José dos Campos, and then they traveled to Porto Velho, just arrived. It's on the boat now from Porto Velho to Manaus. And this is the trailer that was built in Germany with German road specifications. So from São Paulo to Porto Velho, it's broken twice. You need to fix during the way, but finally it's on the boat, so there is only more 200 kilometers from Manaus to Balbina, and the radar will be installed in Balbina. And so this is a scan radar, so we can have ideas about 100 kilometers radius of the convection three-dimensional information. So in Balbina it's covered the ATTO very well. So we hope to have very nice results. I just show some of these results. Can see that's more to highlight the importance of this radar. This radar is what we call dual polarization radar because the emission in the horizontal and the vertical. So we have the reflectivity, that's the basic parameters of the radar, that reflectivity is associated to rainfall. So we have the three-dimensional distribution of the cloud dropper concentrations. But you also have what you call ZDR, that is relationship between horizontal and vertical, that gives an idea about if the hydrometeor is vertically or horizontally oriented. You have the KDP, that is the difference of phase between horizontal and vertical, so it gives you an idea about the amount of liquid water. You have the correlation, that's in the volume, what's the correlation between vertical and horizontal? That's give you an idea about the mixing of hydrometeor you have, and put it all together in a puzzle logic or any cluster analysis. You can have a classification, vertical classification, like light rain, heavy rain, and graupel, ice, aggregates, so the different kinds of hydrometeor. So it will be very fun to play and look this, how is the structure, the vertical distribution of hydrometeor as function of the aerosols, particles, and so on. You can also have the distribution of cloud tops, and this is the vertical velocity that is from the radar wind profile. That's it's each 10 minutes, right, Rachel? It's now, yeah, it's set up for each 10 minutes. We have information about the vertical velocity, the profile of vertical velocity. So that will be very amazing. You stay in Balbina at least 1.5 years. That's a very sensible radar. We hope that when it arrives, the radar is much more tough than the trailer. I hope so. And so we turn on. Oops. So we also have the radio sound operation there, and these radio sounds, we launch radio sound 1 per day at 12 UTC. It's all for people that's not from meteorological field. That's everybody in the world launch radio sound at that time. And so this data is launched and assimilated in all the global models. So when you need to use these global models, it's relay on the radio sound that was launched at that time. So we managed to have this ATTO, a WMO number. WMO, it's World Meteorological Organization that is responsible for the organization of all the data around the world. So ATTO now has a number of the WMO. So we launched the radio sound, we send it to the Brazilian Weather Service. They put in the global telecommunication system, and everybody assimilate this radio sound. So when you use this data from European Center or from NOAA to start to initialize our models, this model will have this radio sound. So it will be the description of the environment will be much more relying data that was collected there. And during the days, when you have the CAFE flight, we will have, this is the boundary distribution evolution during the day that was provided by Gilberto, that we discussed to launch when the boundary layer is growing and decrease, and at the maximum, so that's 5 radio sounds will be launched, and you need to take care, because during cloud route was very funny, because you got authorization from Air Force to launch the radio sound, and cloud routes had an airplane to fly over the ATTO, and when the airplane was going to ask permission to fly over the ATTO, the Air Force said, no, there is radio sound there, so you cannot fly. So you'll be really, so it was nice because you learned that you cannot launch a radio sound when CAFE you fly, because the idea is that when Halo take off, you fly over the ATTO, and then when they return, they fly again over ATTO before landing. So this is the timing, and we hope to have the integration of the measurement in ATTO and during and for CAFE and for the airplane. So we have the idea to launch this radio sound. You can discuss if you want to give better idea about timing of these 5 radio sounds. We are fully open for the discussion to make a better schedule of these radio sounds. There is also the UAV. That's the Cyprus Institute that is in charge. This UAV will fly up to 4 kilometers high. We hope to have authorization. DIRCEU that is responsible for the license for CAFE, and that is also dealing with this license. We hope to have this license to fly up to 4 kilometers. So there are 2 UAV. This one, that's a big one. That's the idea. Bruno is helping to have the best place to fly the UAV, and probably you'll be in the heliport, close to the harbor. And so this is measure ozone concentration, so the profile. We have several questions about this ozone profile. It is more and more important. The results, new results come up, shows that the ozone has a very important role in the formation of this clusterization from gas to particles. There is association with electrification. We would like to have this airplane flying before clouds, after, before thunderstorm, lightning, to see how change the ozone. So it'll be very important, and more the other one that is easy to operation, that's measure basically aerosol concentration profiles. This is the boat, the cruise that is going to happen in January, the second part of Café. This is a very nice boat from Amazonas State University. It's brand new boat and has facilities, labs, and the idea is to have this cruise that Paulo is supporting and financing this first operation. That's the idea is to travel from Manaus to São Gabriel da Cachoeira from 5 January to 10 days up and then 7 days down the river back to Manaus. And there is all this instrumentation, but it's fully open. Just here in the workshop, Paulo got more 3 or 4 instrumentation. People now is going to sleep on the floor. There is no more rooms, but yeah, you'll be very important. But that's you give information on the side of Amazonas where we don't have much information. It's west of Amazonas, so besides the importance, we also have the idea during the flights of Halo to fly over the boat when they go in this direction, so you have some anchor information on the floor for Halo. And besides the importance of using these boats for during the café, maybe it could be a very important vector to explore in the future much more cruises with these boats from Amazonas University. So this was the campaign, but we also have planning some modeling effort. So we managed to have all these people working on modeling from Got University, from France, the Mezenage, from the Stockholm University, the people run large head simulation. Micro 88 is from Wageningen. IMAC team, the people, oh no, that's what to move. From Max Planck. So trying to, okay, thank you. The DALIs, that is the large head simulation from Wageningen. We want to run some cloud model simulation from, from University of Maryland. That's Henrique Barbosa wants to run also some models. And the icon. No, está. One back. Volta Oops. This will be the last one. Don't be afraid. So we have all these models that is set up to run and cover scales from. Oops. Não funciona. So para trás. And so we can cover from since the since the chemical process, boundary layer, turbulence, up to global models, and you have also the icon that's the Max Planck of Hamburg. Bjorn Steves promised to run with meters the icon over the Amazonas during Café. So I think you'll be very fun because it's very important to the combination of observation and modeling data together to explore the physical process is the tool to really integrate the physical process. And I think that's all we know, all we learn about this integration should be transferred to the model to describe all this process. And so you really need to have this modeling activity together with observation. And this connecting four-dimensional modeling and observation is very important to answer all these scientific questions. Próximo. So I will not go in details, but we have all these questions to be answered from the convective transport of aerosols, up and down, downdrafts, the horizontal transport, as Christoph showed, how change from shallow to deep convection, and the convective cluster outflow. That's one of the main questions for the HALO campaign. Next. And so, yeah, one was jumpy, but that's okay, no problem. And so that is the final one, is the activity that's going to happen during the cafe, is the weather report and monitoring. So a team of people will be every day going to CIPAM, CIPAM, the System of Protection of Amazons, when you have several radars covering the Amazonas and all the meteorological information and trying to figure what's going on, where is the outflow. And this is an example, one of the products you have that is from satellite. In red shows when the system is growing. And yellow, there is no much change, and in green is decreasing. So HALO is looking for this growing system. So you'll be able, each 10 minutes, updated, know the life cycle duration of each of these big guys, that's mass-scale convective systems, if they are really expanding. And so the outflow is very important, and that's what is the target of the cafe. So it will be very important to have this monitoring in real time and looking the place and updating the tripulation. So it's something that you want to have the dynamic of this with the daily report meetings. And I hope everybody will participate in this meeting, that you'll be in the hotel in the afternoon. And when the planning mission for the next days will be discussed as well, the data recorded by the airplane will be presented and scientific question discussed. So that's, we have a team of people that will be participate, but this also welcome everybody that want to join this effort. So thank you very much.
Maybe I'll start with a question. So we've been focusing on the ATTO area because that's where everything is, but obviously the aircraft is going to fly to the Western Amazon. So this search for clean air that Christopher was talking about, is that more likely in other parts of the Amazon? And are there other, I guess there is no other equipment set up like ATTO to rely on for ground-based measurements, but are there other networked observations, to the west of us?
Well, I'm not aware of, but there will be at least the boat, which will be a kind of a really helpful addition. And well, if anybody is aware of any permanent stations towards the west, this might be also interesting anchor points in addition. But indeed, that's largely terra incognita indeed. In satellite data, of course, yeah. Number or mass-wise? Number or mass-wise? So in terms of number, kind of the smaller stuff, which is predominantly secondary, is vastly dominating, right? So the coarse mode, so that's the stuff bigger 1 micrometer. This is mostly biogenic stuff. This is on average, really roughly, let's call it 1% or lower, counted numbers. But of course, if you convert it to mass, to the 3, it's the opposite, right? So mass-wise, the big ones dominate clearly. But for the cloud microphysics, we care about the numbers. So how many potential nuclei are there? This then this kind of defines the number of cloud droplets, essentially, and kind of all the cascading further effects in the clouds. So for the microphysics, number is more important, and they're the secondary ones dominate as far as we understand. But, well, there might be still surprises.
Yes, yes, they are, and they will be back to bring this equipment in February, and that's running.
So now we know what was going on. It was off. So you mentioned that there will be this UAV flight measuring ozone at ATTO, and this is from Cyprus Institute, right? Is from Stratos, and why no VOC is being measured by this UAV?
Yeah, there was that was planning this experimentation for the cafe before COVID, and there was much more, and now they need to reduce. And I don't know if Paulo has more information. Why not VOC there?
Yeah, there will be VOC cartridges. In the same UAV system. In the same Cyprus UAV system. So they will have sensors for ozone, for particles on OPC, you know, small OPC, but also cartridges for VOC collection. So anybody who is able to do analysis of cartridges here at UEA is very welcome to join this set of measurements, because they will be very important.
Thank you. Very nice, the presentation. I just have a short question. Are you having any greenhouse gases in HALO?
Sorry?
Are you having measurements of greenhouse gases in HALO? I didn't, just out of curiosity.
I think it's mostly the reactives. I'm not aware of any greenhouse gas sensor, but this is a question I would pass on to the colleagues in Mainz. I'm not quite sure. No. Was it in the list? Okay. So if we can maybe... Methane, yeah. Yeah, methane, of course, yeah. Well, it would be great to have the...
Project the Christoph presentation.
Christoph, first one.
So if we get the list again, there is also the names of the PIs kind of listed. So I would, for specific question, of course, just refer you on.
But there is no flask sampling capability at all. I think on HALO, I think there was no plan. Yeah.
So methane CO we have, at least. Yeah. So
yeah. So just methane and CO.
Horst Fischer would be your contact if you want to learn some details.
I have a question for the boat trip. So I've seen that you are planning to do filter measurements, so you're collecting filters. Are you also planning to look into the organic species, like with LCMS, for example?
Oh, yeah, on the boat, you mean? Yeah, on the boat, there is, it's underway to build this, but there are several, we are trying to have now, Allianz promise maybe have the UAV with VOC. There is gas, greenhouse gas measurement. You have the particle size distribution, collection of soil, water, and Paulo, would you like to complement something else?
Yeah, there will be, so far, no, you is looking for organic aerosol speciation. Yeah, not anything planned, but the people in Max Planck will collect filters, high-vol filters, so you can do it, or we can install additional filter sampling system, you know. We. Sorry? Oh, that's perfect. Okay.
Yeah,
so it's extremely welcome, you know, and this is absolutely necessary. We have the ACSM, of course, for total organics, but the speciation will be extremely welcome. So if you can do it, just join us. It's not extra, too much extra work because you have already one high vol, but if you want your high vol with the, let's say, cleaner filters, that will be absolutely excellent.
Yeah, we still have some, we need to deal with, it will be our first cruise that need to deal with the contamination from the boat to trying to solve the better we can. But, and also the collection of soil, air, water, it's possible, but I'm not sure if you can put more people on the boat, but you have people there that can do the job. So it's, I think you can talk with Paulo too.
And another important thing is that, you know, we'll write a FAPESP proposal for a new thematic project in the next 2-3 months. And the idea, I will budget on the FAPESP proposal twice a year. Cruises with this boat, because I think the western part of Amazonia should be a top priority in terms of measurements, you know. So just for you to learn that, to know that this is not the last time this boat probably will do this kind of campaigns. We wanted to do it twice a year for the next 5 years, you know, and it will be done.
Yeah, so as you can see, things are growing.
Hello. Christopher or Luis, how do you link the data collected on the boat with the flight? This is, to me, is really far away. How is the gap? How can you make connections?
We have some of the instrumentation have the same measurement of the airplane. So you have some ground measurement in that place. That's the way of kind of anchor the information on the surface, because the airplane, I think the high low is kind of 3,500 meters or so on, the lowest one level, right? No, 500 is possible to fly. 500 meters.
Well, I'm not the pilot, but I think ATTO can go down to a few hundred meters. So essentially, that's also the idea for ATTO, kind of to stitch really the measurements from the ground level, all the way to the stratosphere. So we have this beautiful tower essentially. So that's kind of essentially kind of close. But the same in principle also works for the boat. So having the boat in the source is kind of going up the river with the forest around, and then with ATTO we can extrapolate the properties and parameters essentially all the way to the upper troposphere, stratosphere.
Question? I had one question for Luis. So the new radar that's being installed, where you can see downdrafts, and I think that's fabulous, and it'll be really interesting, I think. But what's the area coverage where you can see these downdrafts in?
Yeah. When you said new radar, you mean the radar wind profiling company, right? Because the old one, it's it's old as myself.
I'm not an expert.
No,
the one that's the German
that's a
trailer,
vertical point radar. So actually, there is an angle, but it's more vertical. But there is an angle of Rachel, it's 8 degrees. the angle. Open 12 degrees angle.
12 degrees, so you can see the higher
Yeah.
distance, okay.
Yeah, but there is only one information.
Okay.
Yeah, it's one profile
It's
only.
one profile for, okay.
It's the integration.
Okay, that's cool. And that'll be in Balbina, right? That's. Oh, it's there, okay, all right. Sorry, I wasn't paying enough attention. Okay, more questions? Otherwise, yeah, Gilberto.
Thanks, Chris and Luis, for this nice presentation. My comment is one for Chris and Christopher, the other one is for Luis. Christopher, do you have a map of the planned flights inside Amazonia so far?
A map of the...
To where the plane will go. Ah, okay.
Yeah.
I didn't pay
Not
attention.
sure if that's the latest status, but kind of something along these lines. So I'm clearly sure that there will be also a corridor here going northeast, so ATTO footprint, which is not in there yet. But it looked similar also for Acridicon, and we ended up kind of doing, I think, 3 flights to the northeast and some to the south, and actually one went over the Atlantic. Diseo probably has the latest version, so I'm not quite sure if that's the latest status, but yes, that's...
Yeah, and how many flights will you have at
in the schedule, there's at the moment almost 20 flights
20
planned.
flights.
This is flying every second or every third day, but this then depends, of course, on conditions, but at least there seem to be flight hours for up to 20 flights.
Okay, thank you. And for Luis, and how many sounds do you intend to release to attend all the flights?
So, just to complement, that is what you sent to be approved, but the real flight plan will be decided during the next day operation, the day before the flight. So we have 120 radio sondes split in 2 phases. You have 60. So the idea is we can fit 1 per day and 5 during the flight days.
Okay, thank you.
And just out of curiosity, so for the modeling component, I mean, I'm assuming everybody is going to run their models for the period of the flight campaign, but what's the sort of timing when that's going to happen? Well, obviously later, but is this a sort of ongoing activity, or is it, there's a specific time planned for when people are going to run their models and compare?
Yeah, the idea is to have these 20 flight days as the golden days to be simulated. So we intend to have a workshop just in February or March, just after the campaign, to really decide. But I think you'll be just after the workshop, people start to run the models, and so I maybe more 2 months to have all these simulations. And from ICON, it's probably be run in real time, so it's probably every day.
Okay, cool. Although, from the perspective of the land surface flux part, we know ICON needs some work, but that's...
Yeah, that's what need to be fixed.
Yeah. Okay. All right, thanks. Anybody else have a comment or question? If not, then I think we have a coffee break and come back at 11 and we'll talk more about climate.
¿Tú tienes una computadora para
Okay. Okay, very good.
Good morning, everybody. We'll start our physical climate session with the 3-minute presentations. I would like to invite Gilberto Fisch to give his... Gilberto will give 2 talks together. So he'll give an overview of the Amazonian PBL characteristics, and then he'll talk about the ATTO Tower stuff. Gilberto.
Okay, thanks, Nelson. Good morning, everybody. So, well, my name is Gilberto Fisch. I have been working with boundary layer characteristics and collecting data for a long time. And I brought for this scientific conference 2 papers that myself and my colleagues, we are conducting with this subject. So the first one is an overview of the Amazonian PBL characteristics that was a PhD work that the first author, Raionil Carneiro, unfortunately he is not here, but he is working with our group. And the idea was to use, do we have a pointer? Okay. Thanks. So the idea was that during the Go Amazon experiment, field experiment that was held in 2014-15, so there was a lot of instruments that measure the PBL characteristics, like a ceilometer, like a radio sondes, wind profilers, sonar, microwave radiometers, and lidars. So this is a part of Raionil's PhD. So Raionil put all these numbers together and tried to identify the best estimate of the PBL heights during dry season and wet season and dry season. So this is for the numbers that we had for 2014 and 2015. Sorry, this is for the wet season, this is the dry season. As you can see, the dry season has a deeper boundary layer compared with the wet season. And 2015 was El Nino years, so the conditions, the soil conditions was much drier than the previous year. And the PBL respond to that. So if you have a more, if you would like to discuss this topic, please come to see me at the poster. Thank you very much. Please, the next one. Okay, the second one is again work that Raionil, myself, and Cleo, we are working together, and this work is trying to correlate the boundary layer characteristics at the ATTO Tower. In 2019, which was the last scientific meeting that we had, exactly at this point here. So Cleo, myself, Stefan, Santiago, and many others people, we sit down during the scientific conference and we started to work together. And then the COVID, the pandemic came, and then we still continue to work together by the internet. We did a lot of meetings by the internet. And at the end, we set up some very nice information about characteristics of the PBL at ATTO. So this is one of the results that we had when we compare ceilometer data from ATTO from 2000, was just a 1 month, November 2015, and then we compared with ERA 5 reanalysis, and then we discovered that we had a lot of difference between the reanalysis and the reobservations, and we proposed a correction for this. For these outputs, we have used ceilometer data and also radio sondes. You can see here the points that represent the evolution of the PBL. And also during 2021, September, October, it was the first field radio sounds experiment conducted by Stefan, Luis, Rosa from Amazon State University. And then we start to do some time evolution of the growth of the boundary layer during these 3 days. Now I know that they had a new experiment about August, September with people from Wageningen University. So there are more information that to be analyzed in the near future. So again, if you like to discuss more about the PBL at ATTO's Tower, please come to see me. And the good thing is that the two posters, they are one side besides the other one. So you can discuss both of them. Thank you very much.
Okay, now we invite Daiane to talk about topography-induced spatial variability at the ATTO site.
Good morning. My name is Daiane. I'm a former postdoc at ATTO. And now I'm working at the University of Urbino in Italy. Here I will present some preliminary results from work operation with Raissa, Cleo, Luca Mortarini, and Umberto Giostra. In this work, the main idea is to investigate, to study the influence of wind direction, on the turbulence and the wind profiles using the real topography of ATTO site. So here we have a topography of ATTO. The red point is the ATTO tower, the tall tower, and the blue point is the stunt tower. So this is our domain, the domain that we are using in the model. The domain has 3.6 kilometers by 3.6 kilometer. And, okay. So here we have the wind profile evolution to both wind directions. And if you want more details about our work, so if you can visit our poster. So thank you.
Thank you. Okay. Next we have Raissa Oliveira, again talking about the influence of topography at the ATTO site. So that will be interesting.
Bom dia, meu nome é Raissa. Em conjunto com o professor Dr. Cléo Quaresma e a doutora Daiane Brodani, nós investigamos a influência da topografia no escoamento turbulento entre a floresta amazônica central e a atmosfera. De acordo com os papers de dia junho de 2019 e Chamec 2020, os primeiros a usarem dados acima de uma subcamada rugosa detectaram a inexistência da subcamada inicial, que não possibilita, então, a aplicação da teoria de similaridade de Milbukov para estimar fluxos turbulentos. E, de acordo com esses autores, a floresta e a topografia criaram uma condição dessa ausência da subcamada inicial, ou seja, foi necessário um estudo, uma investigação sobre a influência da topografia em conjunto com a floresta no escoamento turbulento dentro e acima do dossel florestal. Com isso, nós utilizamos dados observacionais coletados através de 2 torres no sítio ATTO, e esses dados observacionais foram utilizados como dado de entrada para condições iniciais de um modelo baseado em simulações de grandes vórtices, mais especificamente um modelo Palm, e através desse modelo nós visualizamos que realmente a topografia tem uma influência no escoamento turbulento dentro e acima do dossel florestal. Para mais informações, para visualização de outros resultados, é só chegar lá no paper.
Okay. Next we'll have Norma Costa talking about the simulation of turbulent flow in the nocturnal boundary layer. So we're changing from day to night now.
Bom dia a todos. Eu me chamo Norma Cabral, eu sou aluna de mestrado do IMPA e orientanda do Dr. Cléo Quaresma. E o título do meu trabalho é a simulação do fluxo turbulento na camada limite noturna amazônica. A ideia principal desse trabalho era utilizar o Large Edge Simulation, especificamente o modelo Les-Palme, para simular o escoamento turbulento na camada limite noturna sobre a região de floresta na Amazônia. E isso foi feito com a finalidade de ter um entendimento não só sobre a organização da turbulência no interior e acima do dossel, mas também compreender como se comporta a concentração de escalar passivo e como ele é transportado sob regime de vento fraco. Então, como resultados obtidos, foram plotados em forma desses perfis, que são mostrados nas três figuras acima, os quais correspondem ao componente da velocidade horizontal do vento, energia cinética turbulenta, TKE, e o fluxo de momento, respectivamente. Já os cortes transversais, mostrados nas três figuras abaixo, correspondem a componente vertical da velocidade do vento, a temperatura superficial e ao escalar passivo. E esse é o meu pôster, e em casos de dúvidas e questionamentos é só procurar. Obrigada.
Okay, now we invite Luca Mortarini to talk about the cospectral budget model for eddy viscosity above the forest. Luca, please.
Buongiorno a tutti. I'm going to present on behalf of my co-authors a cospectral budget model for eddy viscosity and loss of the wall adjustment above the forest. So at this point, you have already decided not to see my poster, but you should. Because, you know, here we talk a lot about fluxes, but when we evaluate a flux, we are never certain we are doing it in the right way. On top of that, when we talk about models, we have to take into account that above the forest, the surface and the atmosphere shake hands in the roughness sublayer, a layer we do not really understand on a theoretical basis. So the idea is to write a parameterization that is not based on the mixing layer analogy, and in principle it should work also in sparse canopies over urban boundary layers, and not to take into account one single length scale, but all the turbulent spectra. The idea is simple. You go from a standard closure for Rand's model. This is the closure all of you are using when you are using WRF, and pass to a cospectral budget, or you don't use a single number, you use all the length scale in the spectra. Here is some spoiler on the results. The model is able to provide directly an eddy viscosity derived from the turbulent spectra and a new stability function which introduce a new length scale. So this length scale is the wall-attached eddies of the boundary layer, but it should be normalized by a dissipation length scale, which is a new length scale. And so, please see our posters. Thank you.
Okay. Who is Correa? Where's Polari? Welcome, please. He'll talk about gravity waves. Different stuff now.
Fica bem em frente. Aqui é o laser e aqui você passa. Mas só tem isso. Tá bom.
Bom dia a todos. Meu nome é Polari Batista Correa. O meu trabalho é sobre ondas de gravidade na camada limite noturna amazônica, onde foram analisadas nos sítios em diferentes sítios, né? No sítio ATTO, no sítio F2 e no sítio Jaru. Foram identificadas as ondas de gravidade, que é um evento que influencia diretamente no escoamento, nos fluxos de escalares de energia na camada limite noturna. Foi identificada a onda de gravidade através da análise wavelet complexity Morley. Feita uma microclimatologia, digamos assim, dos eventos, analisando duração, escala, horário de ocorrência nos diferentes sítios. Foram analisados, através da aplicação das wavelets, o fluxo de calor sensível, fluxo de calor latente, fluxo de CO2, e foram analisadas para cada sítio. E também a influência nos escalares como CO2, CO e metano, como isso interage, como a onda de gravidade influencia nesses fluxos de escalares. Mais informações estarei lá no post. Thank you.
All right, now we'll have Annie Mendonça talking about the turbulence regimes in, again, the nocturnal boundary layer.
Olá, bom dia a todos. Eu me chamo Annie Mendonça, eu sou aluna de doutorado do IMPA e hoje no paper eu trouxe o trabalho sobre os regimes de turbulência na camada limite noturna sobre a floresta amazônica. Nós utilizamos dados de 2 diferentes sítios. O primeiro, nós analisamos 3 níveis acima do dossel, através de sensores instalados na torre K34, que fica localizado na F2. Utilizamos dados do período seco e chuvoso do ano de 2014. Também utilizamos dados da torre ATTO, em 13 diferentes níveis, sendo 2 da torre instante e os demais da torre maior, né? Os dados estão de setembro de 2021 a janeiro de 2022. Aqui são algumas imagens da torre e dos sensores. Alguns resultados que a gente encontrou é que existem 2 regimes de turbulência acima do dossel florestal, um regime de turbulência fraco e um regime de turbulência forte. Esse regime de turbulência ele muda de acordo com uma determinada velocidade do vento, chamada velocidade limiar. E para ambos os sítios a gente observou isso acima do dossel. E que essa velocidade do vento ela aumenta conforme a distância do dossel também aumenta. Entretanto, para o sítio ATTO, a gente observou que a partir de 196 metros, essa distância é a mesma. Ou seja, esse regime muda a partir da mesma velocidade do vento. Então, para mais detalhes, lá no pôster. Muito obrigada.
All right, now we invite Maurício Oliveira to talk about the turbulence evolution at the ATTO site in convective storms. Welcome, Maurício. Thanks.
So, hello, everyone. My name is Maurício Oliveira. I'm a postdoc for ATTO, and I work at the Federal University of Santa Maria. And here in this study, we are understanding the turbulence evolution inside the convective storms that impact the ATTO towers. And we are classifying these storms in terms of their degree of organization. You have the... no problem. All right, so convective storms can produce extreme turbulence in the boundary layer, sometimes even 10 times larger than what you get usually in daytime boundary layers. And this is very poorly captured in numerical models. Sometimes you're trying to simulate tornadoes and stuff and you just can't, believe me, and that's because you're poorly representing these surface fluxes. So this is an example of a simulated storm, and if you look inside the convective outflow, the precipitation, there is a lot of turbulence that we don't yet fully understand. And moreover, you can also have extreme mass heat and I guess, VOCs and ozone exchanges between the forest and the atmosphere in this kind of extreme situation. Oops. Yeah, so this is a figure from a previous work we did with a very small sample of storms, and sometimes you can get even very significant dipoles of sensible heat fluxes when you have these storms impact the ATTO tower. So in this study, we are going a bit further and classifying storms into 3 types, which they vary from weakly organized storms to very organized storms. And we are selecting based on the Manaus Doppler radar and using the ATTO towers to investigate the evolution of these turbulence fields inside the storms. If you're more interested, please come check our poster for more discussions. Thank you.
Okay, now we invite Denise, excuse me.
Olá, bom dia a todos. Meu nome é Denise Holanda Hall e eu vou apresentar um pouco do nosso trabalho. É um estudo preliminar da minha tese de doutorado. Ele tem como título um estudo comparativo de balanço de energia em uma área urbana e de floresta na Amazônia Central. Bom, apresentar um pouco do overview do nosso trabalho. 2 perguntas-chave permeiam este estudo. Primeiro é como a superfície urbana, como a área urbana, ela vai modificar essa troca com entre a superfície e a atmosfera, uma vez que a área de floresta já é bem documentada, esse padrão, como ela vai conseguir modificar essa troca turbulenta entre superfície e atmosfera. E a segunda pergunta é se a floresta ela é capaz de mitigar, se ela atua como um papel mitigador do aquecimento gerado pela cidade, principalmente resultado pelos fenômenos de escala local, como efeito de ilha de calor urbano. Então, para tentar responder essas 2 perguntas-chave, pretendemos analisar os diferentes balanços de radiação e energia na superfície de floresta e na superfície urbana. Então, na superfície de floresta, utilizando os dados da torre da Instant, com nível de 81 metros, e na área da cidade de Manaus, temos uma torre de monitoramento micrometeorológico inédito, a primeira torre numa região de cidade na Amazônia, e ambos os dados vão servir para avaliar o comportamento das componentes do balanço de radiação e energia. Bom, compreender as trocas entre a superfície e a atmosfera no ambiente de floresta e na cidade é um pouco desafiador para Manaus, uma vez que a literatura na cidade para outros locais mostra que a energia particionada ela é fortemente convertida em calor sensível, e aí fica uma dúvida se isso ocorre realmente para Manaus, uma vez que Manaus está cercada por uma floresta, a maior floresta tropical, e também temos o efeito do rio influenciando nos transportes horizontais. Em relação à troca, obviamente que esse balanço ele é modificado, uma vez que a gente tem constituintes, temos elementos de rugosidades que têm alta capacidade de absorção de energia, tem alta capacidade de reflexão e emissão. Então, tudo isso vai estar associado também com os poluentes da atmosfera, afetando diretamente o balanço de radiação e em como a energia disponível vai estar convertida nos processos de calor sensível e latente. Então, esse resultado preliminar do balanço de energia mostra que, na área de floresta, o calor latente, obviamente, ele domina esse processo dessa energia disponível, principalmente pelo processo de evapotranspiração, e na cidade, nesse mesmo período, vale ressaltar que esse período é um período de seco para chuvoso, é um período de transição. Essa energia foi convertida de forma equivalente nos fluxos de calor sensível e latente, tendo um destaque para o calor latente, sendo dominado também pelo efeito da umidade. Então, a água ela tem um papel preponderante nessas estimativas, na avaliação do balanço, uma vez que ela, além das chuvas que aconteceram durante esse período serem acima da média, da normal climatológica, a condição de umidade do solo ele é determinante, além do transporte horizontal, tanto da brisa do rio quanto da floresta. Então, eu convido vocês para ver um pouquinho do meu trabalho num pôster. Muito obrigada.
Okay, I guess that's the end of our session, so we're moving out for the posters, right? Okay. Nice having you. Talk to you outside. Let's have good discussions.
Good afternoon. I hope everybody recover now and have a good lunch. So we are going to continue now. So we start now the discussion part, the important part of this workshop. And we have these 3 parallel breakout sessions. The carbon cycle with Carlos Sierra, bioaerosols and forest biodiversity, with Sibeli, Silvia, Jürgen online, Bettina online, and the soil and water cycle with Gerd. And the idea now is that each one of them gives you a brief overview of what is going to be discussed in this session. Then we will separate in 3 groups according to your interest, in which group do you want to go. One group will stay here, and the other 2 groups will go to another building. And then we will meet again for the next poster session. That's the last poster session, session 4, bioaerosols, cloud, and biogeochemistry. Before that, we have a brief introduction from CMPQ funded projects. No? Okay, so Sibeli, Gerd, Carlos, if you could come here and just give a brief introduction of what you want to discuss in these breakout sessions. Here, not my bad example.
Okay, well, I will lead the discussion on carbon cycle, and the idea of this session will be to first get updates, so we tell each other what we are doing in terms of carbon cycle research. Many of us are working in different aspects of the carbon cycle, so the idea is that first we get updates, so we are all on the same page of what is being done. The second part will be about identifying gaps. Now that we know more or less what we are doing, it's also a good opportunity to identify those gaps and see what are the things that we are not measuring and what are the things that are important to measure, and try to get organized about next steps. And the third part of the session will be to think about synthesis activities, whether we can come together and write maybe a review paper, a synthesis paper about the carbon cycle in ATTO or in the Central Amazon region. So that's it.
Hello everyone, I'm here on behalf of Sylvia that suggested this session but could not come because of personal reason. So we are going to talk about forest biodiversity. So the idea is mainly discuss what do we have right now, what are the challenges that we are all facing regarding identification, how to actually put everything together and join effort for like future samplings, this kind of stuff. So feel free to join us, and for the ones online, we are gonna be with you soon.
Hello, everybody. It's the same for the soil and the water cycle. I think we met 2 years ago, also in the same location, and started the initiative to look if we can close somehow the water budget of the whole system, because we have no real projects which work on this. And the idea would be, as Carlos said, have an update. Who is interested in this? Yeah, everybody is welcome, and then see what new kind of activities we can do.
Okay, so according to which group you would be interested to participate, we will go together now, or we'll separate now. And as I said, one group would stay here. I think Carlos' group will stay here. And the other 2 groups will go to another building where they will have also access to internet. And we meet again at 3 o'clock. We have a coffee break at 3 o'clock. So you have time until 3 o'clock to discuss. Then we have coffee break, and then we continue with the presentations. Okay? Where is Bruno? I hope everybody had a nice discussions in the breakout sessions. And Eliane just wants to make a small announcement.
Yes, so people were asking about any social event that we could have during the workshop. And today there is a very traditional and cultural event in the city center at the Opera House Square called Takakana Bossa, which is local live music. And in this square, there are also some good restaurants with good fish and also veggie options for vegetarians. So we were thinking of going to this event after the workshop. So.
Okay, now I give to Beto. Beto?
Hi, everybody. It's me. So this section is supposed just to give a brief report of what the new CNPq, the recently approved new CNPq proposals are about. So we had these proposals. No, I mean, when was it? Not very long ago. End of, yeah, something. Yes, yes, was announced, and then the actual run for the proposals was about, and people got the results not very long ago, and we got 6 proposals approved. 5 of them were already from people who belong to our, belong to the group. So those people have been gifted with funding Jochen Schongert, Gilberto Fisch, Otávio Acevedo, Raquel, yes, Ricardo Godoy, and one person from the Unesp, Rio Claro, a professor there called DJ Gastmans that is not here with us today. In the end, I will just say what is that he does, and hopefully next time he will be around with us sharing, and also we need to be prepared to share data with him so he can actually do the work. So this is a construction that needs to be done yet. I'm not entirely sure how much construction of the proposal with collaborators from ATTO has been done, but this is something we will do in the due course. So I don't think I need to delay any more from that. Just say that the funding was basically towards funding people to work on existing data sets, right? So all the funding that people got on these proposals were dedicated exclusively for funding people's time. So you get a postdoc or you get 2 postdocs. So this was a decision. There was a fixed amount of money, and this was a decision of the researcher how to apply funds. It's only exclusively into people, since we get funded already, isn't it? So we have maintenance, we have all the machines working there. So basically, what was lacking pretty much was people. So that's why it was designed this way. So without say any long thing, people need for doing the presentation. Who is the one? Who is the first one? I think this is you, Jochen. So please go. Okay.
So, good afternoon, everybody. My name is Jochen Schöngert. I'm here from the research group Ecology Monitoring and Sustainability. And I will give a very short presentation on our proposal, project proposal, which was now approved in this call from the CNPq, focusing on the diversity of hydrofunctional traits from different ecosystems along gradients, hydrological and climatic gradients, which is a counterpart to the project ATTO Hydrotraits financed by the Ministry, German Federal Ministry of Education and Research, the BMBF, which is coordinated by Dr. Florian Wittmann from the Karlsruhe Institute for Technology. So first of all, I was very positively surprised with this call because it's an excellent opportunity to insert a critical mass of young Brazilian researchers in the ATTO project to at least counterbalance a bit this this difference of the amount of researchers that we have in this bilateral project. So that was a very good opportunity, and when we heard about it, we made huge efforts to write the proposal, and we got it approved. We already have persons acting in this project, and so the scholarships are already implemented and effective in this project. Does not work. Where I have to point out to here? Sorry. So the main objective of our proposal is, in contrast to many other projects from the ATTO, we are going into the footprint of the ATTO Tower to provide an ecological background, also on the ecological characteristics of the dominating tree species there, along a huge climate gradient which goes from the central Amazon and from the ATTO side, where we have about 2-3 months of precipitation, less than 100 millimeter per month, to the eastern Amazon, where we have already a dry season length of about 5 to 6 months, focusing on 3 different ecosystems which are quite characteristic in the landscape of this region, which are the terra firme sites, the white sand ecosystem, the Campinaranas, and also the floodplains. In this case are Igapó floodplains, which are nutrient poor. So we will provide data on species richness, species composition of trees from these different ecosystems. We select the most abundant tree species, 10 species from each ecosystem at each site, to provide information on functional traits on the leaf, wood level. Also, we make analysis of the tree rings to get information on the age, on the growth rates in diameter of these species, making also creating a bibliothèque of these informations, applying the near infrared spectrometry near, and also trying to extend that on a landscape level, applying remote sensing techniques. So here, this is more or less the design of our project. Now we have 4 sites here: the ATTO site, Uatumã, Abacate, then the Trompetas, Tapajós, and the Xingu site, where we make the floristic inventories, estimate of the biomass stocks along this hydrological gradient from the non-flooded sites to the white sand ecosystems, and then to the Igapós, which are long-term flooded for several months per year on average. So we have this hydrological gradient at each site, and here along these sites we have this huge climate gradient from the central Amazon region to the eastern Amazon region. We had a huge excursion which came back just a week ago, which performed already all the inventory, the determination of the functional traits from the tree species here from the Xingu side, and on 17th of October now we have an excursion to also complete our data sets from the Uatumã side, and then in February, March we will have an excursion to the Trompeta side, and probably in the dry season of the next year to the Tapajós side to complete our inventory data and perform the analysis. We have quite a nice group of researchers from different institutes. So it's Florian Wittmann, which is the German coordinator, and me, which is coordinating this project from the CNPq. It's Dr. Maria Teresa Fernandez Piedade, here from the MOA group of INPA, Dr. Susan Trumbo from the Max Planck Institute for Biogeochemistry, Gisele Mori and Flavia Machado Durganci, which are contracted by the KIT, acting as postdocs within this project. Adriano Costa Caresma, also from KIT, Dr. Eliane Gomez Alves from the Max Planck Institute for Biogeochemistry, and then we have several students performing her PhD or master, like Ilana Luise Adlich, which is making her PhD here at the graduate course in botany of INPA, Gloria Vieira Rodrigues, making her master at the program, graduate program of Science of Tropical Forests. Caroline Lorenzi Marman, which is making her PhD in Geography of the Federal University of Santa Maria. And here are our new 3 students which have already their fellowship implemented by the CNPq, Priscilla Amaral de Sá, Mayra Luciana Guimarães Conde, and Caroline da Cruz Vasconcelos, which are all present here, I think. Priscilla, she makes mainly the analysis of wood anatomical characteristics to focus on the hydrological vulnerability of these tree species. Mayra Luciana will provide data on the growth rates and the tree age of the species, and Caroline da Cruz will support us in the identification of all the tree species along these gradients that we investigate within this project. So that's it. Thank you.
Thanks, Joachim. Not sure who is next. Ricardo Godoy? Godoy? Please, man.
So, good afternoon, everybody. My name is Ricardo Godoy from Federal University of Paraná. Basically, I would like to say something about the conception of this project and then show some details. So, basically, as most of you had been in ATTO and climbed the tower, so I was there in 2015, 18, I think, and I observed something that took my attention. It was one type of fog, or is fog, but type of cloud over the canopy. And this took me attention, and I was thinking why we have this situation on the canopy. Later on, I had the opportunity to be the advisor of Cibele, and Cibele was a lot of years studying the pollens and the fungi and biogenic particles in the column of the tower. And she found a lot of biogenic particles, pollens and fungi at 300 meters. And this took me attention, and it was quite hard to justify why we have these biogenics at so high altitude. And later, the snapshot is that I had the chance to talk to Sebastian Brill, and most of you saw a nice movie that he had showing the spore production at the ground level. So when I had all these informations together, I was thinking, why not to study the fog that we have that is formating in the morning at the ATTO Tower and goes up. So this is the main idea of the proposal. So we have a lot of colleagues from Brazil, from UEA, from UFPR, from USP, from UNESP. But also we have a lot of colleagues from PNRL, Pacific Northwest Lab, and the Max Planck, that is Christopher and Andy, and Manchester Metropolitan University, Harvard and Coventry University. So a lot of colleagues are interested to understand what happens when we have this fog formation, in the sense of what is the role of this fog formation. So basically we set up one experiment or some experiments that is basically collected single particles using cascade impactor. So collect particles and analyze individually these, especially with the scanning electron microscopy with the EDX. Make some experiments with ice nucleation. So basically on single particles. And then we had the opportunity to have one fog collector. So at 42 meters high, we installed this fog collector. And then with this liquid that comes from the fog, we can analyze a lot of, make a speciation of a lot of compounds like ion chromatography with cations and anions and particles distribution, orbital traps, high resolution mass spectrometers. I mean, we can study different compounds and different compositions inside of this liquid, this fog. And also, we are sampling total PM particulate matter on filters that allow us to make another speciation like nanodesi to understand and see which type of organic compounds we have on the filter that comes from the fog. So basically, this is the proposal. We have opportunity to contract one postdoc that will be 2 years longer working with us. Besides Bruna, that's our Highlander. You know, Bruna will make the Master of Science using almost all these informations. Part of the analysis will be made in Brazil, in my lab, in labs of my friends here in Brazil, but some of the experiments will be in PNNL, like orbital trap, nanodesi, and single particles will be performed there. No? From my point of view, it's a nice approach. It's something that I never saw in the open literature and took my attention. So based on this knowledge, I think that we can develop some interpretation what happens with the particles or the biogenic particles dispersions in the open air. That's all. Thank you.
Otávio, where are you, Otávio? Obrigado, professor. Nos ilumine.
Hi, everybody. I'm Otávio Acevedo. I'm from University in Santa Maria in southern Brazil. This is the team that we put together for this proposal. There are people from Brazil, colleagues from Germany, and also from Italy. We got 2 postdoc positions, which have been assigned already to Luiz Gustavo Martins and Claudio Teichrieb. The title of the proposal is Atmospheric Turbulence Regimes in the Amazon. And I'll try to give an idea why do we care for this, what we can do with this, and some very preliminary results from Luiz Gustavo. So why do we care about turbulence regimes? In nighttime, people have shown some of that already. Any poster for one thing. The 2 regimes are typically referred as the weakly stable and very stable regime, and they are really, really different. In the weakly stable, turbulence is continuous. It's very well mixed horizontally, which means that any given observation is representative of a larger area. In general, models work with some restrictions, of course, but they do a decent job. In the very stable regime, which is usually weaker winds, larger stability, larger temperature, thermal gradients, turbulence might be intermittent or even almost non-existent. Horizontal gradients are huge. You can have tens of degrees of difference in temperature over hundreds of meters of distance. And the models fail terribly in general. You do not forecast well weather, you do not forecast well climate, you do not forecast well air quality. The parameterizations for fluxes that go, and you do not forecast those things well because the parameterizations of the flux that go in those models do not work. So this is from a previous paper that we published 2020, I believe, where we kind of, for 3 different sites, we showed that the turbulence regime, it's not a the switch between one and the other regime at night depends on things like net radiation and wind speed. It's not a difficult relationship, but it seems to be a linear relationship at each site with a different slope in this relationship, which is site dependent. I will not go into detail, but this is something that we'd like to check for the Amazon with a very peculiar characteristic and the really large amount of data that we have from the ATTO Tower. So we can implement this and have some way of improving the models, at least to have a better handle on when the switch between working and not working goes. Then we need also to get somehow to make it work in the very stable regime, but that might be a more critical step. Now, at daytime, the difference exists, but they are not as critical as in nighttime. The two different regimes are not so contrasting in daytime, but they are called forced convections, where the thermals are distorted horizontally. Typical flux formulations are meant for this situation, and in free convection, I forgot, I just didn't correct here, but in free convection, the thing is the thermals are vertical. Thermals tend to be vertical, and you need a specific parameterization for flux, which is called free convection similarity, things, something like this. It's not that different, but things like boundary layer growth might be different. Even the daily cycles of variables as temperature, as concentrations might be slightly dependent on the regime. For just these are plots that Luis Gustavo, who could not come today because he just started in the project. So the project, so there was no way to bring him. He hadn't even been assigned to the personnel of the project. But he sent me why we are here, and this relates to things that we have been discussing here. So I thought it might be interesting to show. This is one day in which he classifies as forced convection, probably based on the dominant TK production terms. But this here, you can see this is temperature. You can see the stable boundary layer, then the unstable boundary layer here, wind speed, turbulent kinetic energy, but I call your attention to the heat flux. This is the heat flux. You can see here as the convective boundary layer forms, the heat flux go, the profile, you have these structures that go all the way. But in particular, this thing here is the entrainment layer. It's very well defined entrainment layer. We discussed this. And which might be interesting for a number of applications here. We can do even something similar for CO2 entrainment and humidity entrainment. When you, this now is average flux, average heat flux profiles for days of forced convection. And this is very interesting. You can see how here the convective boundary layer growing, which is very nice as it goes. I'm not sure if you can read here, but this is 7:30 in the morning, 8:30, 9:30, 10:30, 11:30, and then you can see the growth of the convective boundary layer. But I call your attention to some specific facts. One thing, the theory says the heat flux has a linear profile, as you can see here, that converges to zero at the top of the boundary layer. So we can have a very nice estimate of the top of the boundary layer, except that we need to account for entrainment. We do not exactly know how much of entrainment you have here. Typically, it's 20%. So you need to add above this point here 20% because the flux will go negative at 20%. Is that right? Well, we are not sure, but we can tell that at 8:30, yes, that's exactly right. It's exactly 20%. You have an exact estimate, observational, we are looking observationally at the entire profile of the boundary layer with an exactly an accurate estimate of entrainment rates. This is very good for modeling. This is very good to understanding the boundary layer growth. Here, just finally call your attention to the transition here as the transition to the stable boundary layer, and I think this is very nice. You see you have a very shallow 50-meter stable boundary layer forming, and then you have say a residual layer, you can call that, it's not here, and then this is at this moment here you probably have really large variations in scalar concentrations because you have such a shallow layer in a very small period. We have to confirm all these kind of things. Okay, this is the idea. Thank you.
Thanks, Otávio. I guess we leave any questions for the end, okay? So now I'm Gilberto.
Good afternoon, everybody, again. So my name is Gilberto Fisch, and I will present our proposal that has been granted for this next 2 years. So, as the others, my colleagues, they announced that this was an announced opportunity launched as a number 01 by 2022. And the name of our, our project is Observational and Numeric Study of the planetary boundary layer for ATTO involved micrometeorology and the chemistry of the atmosphere. The idea was to link some dynamics of the atmosphere using observations and numerical models and try to correlate with some species that is exchanged between inside vegetation and the atmosphere. And our group, which is very short, but is completely open for new scientists, students, and so on. It's Cleo and myself as a PI, and the 3 students that they will got their scholarship for the next 2 years. So Raionil Carneiro was, as I mentioned this morning, he was my PhD student, so he's involved in my project, so he knows everything about ATTO, about Go Amazon, how to run some models. Flávio Faria de Oliveira, he was a PhD student from Cleo. He just finished his PhD by June or July using WRF. And Carla, she finished her undergraduation meteorology course at University Federal of Pará. So they will start, say, Flávio will start this month, and Raionil December, Carla maybe next year, and we have 2 years for Raionil and Flávio, and 1 year for Carla. And what we would like to study for this project. So as Beto mentioned in the beginning of the session, so there are data, there are some results that have been learned, and we name as learned lessons, and especially in terms of observations. So this both graphic here I showed this morning. So they are the behavior of the planetary boundary layer at ATTO. So we have some experience in doing this kind of analysis. Of course, we would like to improve that using much more data that is becoming available, like data collected at Campina site, the radio sounds that were made last 2 months ago, the new experiment for Café Brazil that will bring a lot of new data using aircraft that we can use it. But also, well, this just to mention, this is a paper that analyzes how the ERA 5 represents the PBL at not only at ATTO but also in the Go Amazon. It's a paper that we started 3 years ago here and was published by this magazine here, Remote Sciences. Claire was the leader of it. So Luis is involved, Stefan, Christoph, and others. But also, Rai O'Neill, Carneiro, and myself, was a paper published in ACP. We started to study the erosion of nocturnal boundary layer and what is its influence on the development of the clouds. So Rai O'Neill just make this analysis. He didn't go further on how the clouds will evolve. But another student from Luis and myself, Alice Hankes, she finished her PhD last December and published a paper in ACP 2021. And she characterized the structure of the boundary layer for days with shallow convections and the characteristic of the PBL on days with the deep convections, and using data from Go Amazon. And we would like to improve this analysis and go further with the data from ATTO to see if the clouds developed over ATTO is more or less the same as the clouds that is developed at Manacapuru site. Also, in terms of numeric simulations, I had this Master of Science student at INPE. He presented his poster on the first day, Tuesday. So he did some numerical simulations using WRF with a 3 nested grid with the central point at Go Amazon, but now we would like to move this for ATTO Tower. We will do more or less the same idea, but of course we will couple the WRF with the chemistry model to go further to see how the methane will be exchanged between the atmosphere and inside vegetation. We have analyzed the dynamics and the thermodynamics and the thermodynamics profiles forecasted by the model, and this is something that is new, on my opinion, that usually we have just 1 point or 2 points of profiles, but with the model we can derive for 1 kilometer spatial resolution how is the boundary layer spread in terms of different types of surface, because we have rivers, we have tropical forest, we have large farms, we have cities, and so on. So the idea was to use data from point measurements like ATTO and also the Go Amazon data set, which is very rich, to improve and validate those kind of models and do this kind of analysis that we can bring more information to analyze, for instance, advection of moisture, advection of species at ATTO size. And as an objectives for it, so we would like to go on with the analysis of the PBL in terms of space and time over not only central Amazonia, but considering the whole Amazonia. I will show one slide in the next one. Using this model, WRF chemistry model with the 3 domains, but the inner one will be 1 kilometer, especially focusing on methane, because methane, there is a lot of scientists here studying methane. Santiago Botti is one of them. We are very friendly, so we can exchange with him some results and discuss things. but also because methane is becoming one gas, although it's a greenhouse gas for a long time, but say IPCC is paying attention on greenhouse, on methane right now. In the previous reports, only CO2, but now methane is coming as one of the greenhouse gases important to be forecasted. As I mentioned before, especially because of the PhD from Santiago, there is some scientific questions regarding about the transportation, horizontal transportation from the rivers, or if the Balbinas Dam to the tower site. But we don't have measurements to understand this better. But if we can use models, we can go deeper in this analysis. And also, with this horizontal diversions, we can make a gradient between the river, the Campina site, with a lot of new instruments set up there, and the terra firme at ATTO. And finally, as this morning also, some students, they have showed their posters that they are using a large edge simulation high resolution model, PALM. And so we would like to bring this model also for this community to use it to understand better this three-dimensional flow at the ATTO Tower. And before I show my last one, this is some ongoing studies that we are conducting with this team. So as I mentioned before, O'Neill is working with us for a long time. He will start his new grant in December, because we had already one grant, so let's go up to the end and then start a new one, so we will not lose money. And with the group of Luciana Gattes, Luana Basso is here, using their data site and plus Go Amazon plus ATTO, we are trying to analyze how is the behavior of PBL consider the whole Amazon using ERA 5 data set. So in principle, we are doing some validations of the different methods that we are using for all data set. For those of you who doesn't know much about ERA 5 is a reanalysis from ECWF. They have data since 1980, for instance, so it's almost 40 years for the whole Amazonia. So we can understand better where we have a deeper PBL, where we have a shallow one, if this deforestation is increasing, if the PBL is also decreasing its depth or not, things like that. So this is something that we are doing right now, and we will continue for the next year on. And so this is my contribution for this section. Thank you very much. Dankeschön.
Hello, I'm Raquel, Alberto, or Rachel. Doesn't matter, whatever you call, I will answer. So our project is about not the towers, it's about the Campina site, which is a new experimental site, maybe not so new now because it's running since 2020, but anyways. And it's focused on how can we connect the tower measurements with the upper troposphere and the clouds and everything that is going on up there? So we have a few scientific questions that we put on the proposal. And so mainly we are focusing on how is the transport from surface towards the upper troposphere, and this transport is downdrafts and updrafts from convective clouds. And all that will can participate on new aerosol particle formation that has been a focus nowadays on the science, and also how we transport the gases that plays a role on this particle formation. And particular to myself, I'm interested on the lightning side, how it can work on the chemistry also. And so to do that, we need a place there are no trees. So we went to the Campina, because we are working with remote sensing instruments. So because we want to measure from the surface all the way to the upper troposphere and get the vertical structure of clouds, precipitation, temperature, humidity profiles, and water vapor content, and all several other complementary measurements. And for those who wondering where it is, so we have Campina, which is about 4 kilometers south of the Tall Tower, on the way from Porto Alto to the Tall Tower. And the other instrument that is also part of the Campina, at least for this coming year, is the Expo radar, which is a scanning radar that can take the three-dimensional structure of the clouds and get kind of like a tomography of the cloud and saying like how much of water content we have there, which type of hydrometeors, if it is ice, if it is water droplets, if it is big water droplets or small water droplets, stuff like that, not 3D dimensional. And this radar will be in Balbina. So I put the map here because I've heard some questions this morning on where it will be. And those red lines are the 60-kilometer radius and the 100-kilometer radius coverage of the radar from Balbina. So we'll cover our region of interest. And so on the Campina side, this is another view of the Campina, so we don't have trees to not block it. Our electromagnetic signals up to the troposphere. And we also have one flux tower that is a little bit out of our main site to get actually the structure of the Campinas. And this is a view of the instruments. We have a radar wind profiler, and a cloud profile, cloud radar, which is the one on the lower right. And on the left is the radar wind profiler. Both radars, they look at clouds, but at different size of hydrometeors. So the cloud radar looks when the clouds are forming. And so they take smaller, they can measure smaller droplets, and when we have rain, the signal just gets extinct and we cannot see anything. But then the radar wind profiler takes on and we can see the rain from there. From both we can get updrafts and downdrafts. So we can get the mass flux of air that is coming from the clouds down to the site. And we also have other rainfall measurements like the Parseval and rain gauge. Parseval measures the raindrop size distribution, and we have sailometer, ethylometer, and so micropulse lidar and SMPS to also get some aerosol measurements on the site, and a photometer. And this is just an example of one of the measurements from the cloud radar. So here I'm showing you radar reflectivity, and it is a measure of the content of hydrometeors that we have. So the warm colors are more content. So the y-axis is the height and time on the x-axis. And so we can see that we have very heavy rain. We have actually signal extinction at the beginning. This is like a cloud that hit right our site. And so it starts with heavy rain, so this this radar will not actually get it. But then as the heavy rain passes and we have that very steady rain, more calm one, we start seeing more of the rain. And we get the whole structure. We can see the melting layer where the ice crystals are falling and melting and turning into droplets. Those are like large falling aggregates, and then they melt and turn into rainfall. And here is the Doppler velocity, which we can see stuff going up and down, and we can make some measurements and the calculations and get the fluxes, convective fluxes from that. And we also have some measurements from this radar of kind of what is the microphysical structure, if it is ice or water droplets too. And also planetary boundary layer, what we call plankton, which is bugs. And we can see also fog with this radar and the LiDAR. And so whenever you guys are thinking now of rain, don't think anymore of rain gauges, okay? You have the whole structure of the rainfall that is going down to ATTO. This is the radar wind profiler, which would see the rain itself, but this figure is not good. But it's basically the same thing, just to maybe not show you this. Just go ahead. So the project, it is actually to fund two people to work on the site to guarantee the quality and monitor all the measurements. And another one to work on the data management of the site, because it is a huge amount now of data that we are dealing with. The first spot is filled. Is Chico. I don't know if Chico is here. He got here, there. He'll get the scholarship. And the second one, we did a call, but we didn't find anything that fit the position yet. But we'll open again. So the basic concept, it is, for this project, is not to fund people to only do the science. It's mainly the measurement of the site and the data. And the science is already being done from all the more than 20 collaborators that we have on this project that I didn't list here because it's too many. So we have data from the raw data, level 0, and then we will process to everything, getting quality control. Some stuff is already being done, like this one is for the cloud radar. And with that, we also have like quick looks to just see whatever is happening and the figures. And the idea is, in the end, to have like a website with the operational situation of the site, with all the instruments, if they are working, if there is a problem, if they are transmitting or not. We can see like a small figure, PNG, that can be transmitted and see if whatever is the quality of the data is good. Something like on those lines. And that's it. Thank you.
Thank you. Well, I guess let's go to questions for the people present here. I won't adventure in trying to explain what the other project was funded for. It is pretty much something related. I'm a soil scientist, okay? The title is ATTO. It's something about deep and shallow convection and moisture coming from the Amazon to the rest of Brazil and water transport. And it also involves radar data, isotopic water isotope data, models, and satellite observations. So it's pretty much online with Rachel does, Gilberto does, probably some relationship with Flavia as well. And I will make sure I make the connections and get everybody on the same page. But apart from that, which is some homework for me to do, I apologize Didier Gastmans if he's listening to me. Questions for the people here? No? So I guess it's beer o'clock. Or not? Poster talk first, and then beer o'clock. Okay, you see I am exactly on the page, right? No.
Actually, so we have session 4.
So I think we already had a lot of scientific input for today, and it's already running quite late, and everybody of you wants to have a beer outside, it's waiting. But I hope we still have at least a bit of motivation for our last PCOS for today, also for the last poster session, which is about the aerosol clouds and biogeochemistry. And so the Amazon is a quite complex ecosystem, which is the home of a lot of different life forms, and it also hosts a lot of difficult processes. And the atmosphere above the forest has a strong influence and interaction with this ecosystem. And the aerosols, which are getting emitted from the biosphere or which are formed in the atmosphere or getting transported to the Amazon, have a strong influence about the processes which are happening in the atmosphere. For example, the formation of clouds. So that is mainly what our session will focus on. So which particles getting emitted from the ecosystem Amazon or form in the atmosphere, how they're getting transported on a vertical or horizontal scale, and which processes or which short and long-term effects they have for the Amazon ecosystem. So I think we can start with the first talk, which is a video, I guess.
So the first presenter is Rafael Santos. He unfortunately couldn't be able to join us, but his poster is online on the platform and he has sent us a video.
ATTO Workshop, take 1. ATTO Workshop, take 3. Hi, my name is Rafael. I'm from the ATTO Workshop, take 11. Hi, I'm the University of São Paulo. I'm from Rafael.
2 weeks later.
Hello everybody, I'm Rafael from the University of São Paulo, where as you can see right behind me, it has been raining a lot recently, and this is exactly the focus of our study here, because we have been looking at meteorological conditions in the ATTO Tower, both during the wet and dry seasons, and in 2 height levels at 60 and 325 meter heights, focusing on the vertical profile of a bunch of different variables. And we have found that there are significant differences in the diurnal cycles of temperature and relative humidity and wind speed, for example. And this is part of my master's work, which is exactly the reason why I'm not able to attend in person in this workshop, because I have been writing the essay, the final essay, and I'm expected to finish still this year. And another part of this study is looking at the vertical profile of the aerosol optical properties, for example, such as absorption and scattering coefficients at both height levels, and also the number concentrations in the size modes of the aerosols, and the intensive properties as well, such as the albedo and the angstrom coefficients, for example. We have been looking at the effect of the downdraft events, convective events, in these aerosol properties during the wet season in both height levels. And for that matter, we developed an algorithm to detect downdraft events from the time series of the potential temperature anomaly, also measured in the ATTO Tower. we have found that there are differences in the effect that these downdraft events have in the optical properties and the number concentrations in both height levels. There are differences. And we have also been using the brightness temperature, the ozone concentration, and the precipitation as markers to assess the quality of the detection algorithm as well. Further results will include dry season analysis for the vertical profile of these properties, and feel free to contact me to discuss this work. Have a nice day. See you all.
So the next one is Sebastian Bru.
So hi everybody. So my first presentation for today is about the automatic robotic lift. We call this ROLI for the high resolution profiling for the ATTO Tower. So what you can see here are two vertical profiles of aerosol concentration. On the left is the fine mode, on the right is the coarse mode. And you can see there is a strong variation in the diurnal cycle of the aerosol concentration, but also with the altitude. And we are interested in how this changes between the seasons and also how the diurnal cycles of the particle concentration is. So, because with the online measurements at the ATTO Tower, we always have a view on different levels. So we can look for 300 meters and 80 meters, but we are missing quite a lot of in between. And we have also the problem with the long inlet lines. So what we developed, or our idea was, to have a robotic lift, which is climbing the ATTO Tower of the outer side. So here you can see the rail, which is installed at the edge of the ATTO Tower. And it's an automatic lift which can drive up and down the ATTO Tower, which can be equipped with various instruments, what you want to put inside for particle concentration. We also detect meteorological data regarding temperature, humidity, wind direction, wind speed. So here on the right, here on the left, you can see a drawing, and that's the actual lift. So it looks actually came out good. And right now, our colleagues from our mechanical office and our technicians are installing the lift at the ATTO Tower, and we had some first test runs in these days. So we drove up and down the ATTO Tower. We tested various security scenarios. And on the left, you can see a schematic drawing of the instrument box which will be installed. So we have quite a lot of space for various instruments. So if you have ideas what you want to install in a lift, just come to us and then we can discuss about it. Yeah, that's how it actually looks right now. So it's can drive up and down here, and yeah. So you can program it whatever you want when you want to drive down, the speed and so on. And I want to say thanks to all the people which are involved. So it was since I think 3 years we are now working a lot on this project, and a lot of people were also in the background. And thanks to all of you. And I hope to have a discussion with some of you about what we can put inside.
Bruna Seben.
Hello everyone, I am Bruna. I'm a master's student from Federal University of Paraná, and my advisor is Professor Ricardo Godoy, sitting there. And today I'm going to present to you an overview about this investigation we are having about fog processing of aerosol in Amazonia and their climatic impacts. So I guess many of you must have been at ATTO at least one time, and it's very common for us to see this massive fog forming, especially before the sunrise. And it got us thinking about all of these chemicals that can be within the fog and process happening. And then we decided to start the sampling collections at 42 meters, which is right above the canopy. So we had these 2 sampling completed. The first one last year between October and November. and the second one this year between April and May. And for both of these samples, we had filters, grids, and silicon nitrate. And this year we started to use this fog collector, which gives us this liquid fog. So now we are planning to have this other sampling campaign on October, having all this for measurements. And if you're interested in this subject, please come see my poster. Sorry. And then we can talk about this investigation. Thank you.
Next one, Sebastian Brill, again.
Hi again. So at my last poster was about the robotic lift, and now I want to talk a bit about the aerosols, and because we can also use the robotic lift to measure the vertical profile of aerosols, but it's also important to know which things are getting emitted from the biosphere first before we look into vertical profiles. So what you see here is a aerosol mass size distribution, and you can see this pronounced pattern with much higher aerosol mass concentrations during the night time. And we observe this for basically every day of the year. And we were wondering what this comes from. And we found out that it's mainly fungal spores, because fungal spores in the Amazon account for the major fraction of the aerosol mass, which is getting emitted from the ecosystem, as they are really heavy particles and really big particles. So below the canopy, it's around 95% or over 90% of the aerosol mass comes from fungal spores. So we wanted to know, okay, what is the pattern of these fungal spore emissions? And I have actually a video here. So what you see here is a fungal fruiting body at the ATTO site. So this video was done some days ago. And you can see here, this was in the afternoon at like 5 p.m. And you can see the heavy spore emission of this fruiting body. So it's really heavy, so you can easily see this with your eye. I think it's quite beautiful. And our idea is to know which particles getting mixed up. It's important to know during which time of the day they're getting emitted, because the vertical transport of the particles change during day and night time. So what we did, we went to the field with a particle detector and measured the spore emissions of fungi directly when they grow in the field. And what we found out is that at least the fungi we measured about 50, had a very strong diurnal emission cycle, what you can see below here. And you can see the lowest emissions we get are during like early noon, 11 a.m., and the highest emission of the spores are in the afternoon and in the first half of the night. So there is a strong difference between the spore emissions between day and night time. And yeah, so that is my poster, which is about the fungal spore emissions, and then the next step is to look into vertical profiles, which we will do with the elevator, to then see, okay, we get an accumulation of these particles during nighttime, so how they're getting mixed up when the convection starts in the morning. So if you want to know more about these two topics and how they are connected, please come to my two posters. Thanks.
So next one is Carolina Ramirez. She couldn't join us today, but her posters are outside and of course online, and we also have a presentation from her.
Boa tarde. My name is Carolina Ramirez. I'm a PhD student in the Max Planck Institute for Chemistry, and I am tenor Europe in Lille, France. So my poster is titled Secondary Organic Aerosol Formation Under Pristine Rainforest Conditions. So the aim for this poster is try to characterize the organic aerosol dominated by biogenic emissions under pristine atmospheric conditions in the Amazon rainforest. To do that, we are using a proton transfer reaction mass spectrometry, or PTRMS, that, as you know, is an online technique and real-time detection, but just for organic trace gases in the atmosphere. So to characterize organic aerosol in a molecular level, we are using aerosol inlet coupled to the PTRMS, and in this case is the chemical analysis of aerosol online or current system. So this inlet can measure all the particles and then volatilize them. Particles greater than 125 nanometers, and then those compounds can measure by PTRMS.
Você consegue passar? Sorry. Oh. Pesado. Não. Fica aqui.
I think.
Boa tarde. My name. So the aim for this post real-time detection, but just for organic trace gases in the atmosphere. So to characterize organic aerosol in a molecular level, we are using aerosol inlet coupled to the PTRMS, and in this case is the chemical analysis of aerosol online or current system. So this inlet can measure all the particles and then volatilize them. Particles greater than 125 nanometers, and then those compounds can measure by PTRMS. So we measured at ATTO site during 5 weeks between April and May in 2022 using the PTRMS Caron, and we measured at 2 meters and 80 meters. We measure, of course, aerosol particles, but we measure as well volatile organic compounds in gas phase. In addition, we use the black carbon concentration measured by MAP, the aerosol site distribution measured by the SMPS, and the organic aerosol concentration measured by the ACSM. So we found very interesting results. So, for example, near pristine conditions are observed during the field campaign because the concentration of black carbon was very low. So also we found a high aerosol concentration events after 23 of April, and we characterized the organic aerosol measured by the PTRMS as a function of the number of oxygens of the molecules. So we identified that molecules with 1 and 2 oxygens represent 80% of the organic aerosol reported by the PTRMS Caron, and we identify an increase of high oxygenated compounds from April 23 to 2nd of May. And thank you so much for your attention. If you want to know more about this project, this is my email, and of course, you can come to my poster. Muito obrigada.
So next one is Stephanie Hudman.
Okay, hi, I'm Steffi. I'm a PhD student at the University of Mainz in the group of Professor Thorsten Hoffmann. And the title of my poster is Molecular Characterization of SOA and Precursors in Amazon Rainforest. Coming to short introduction parts, because I think that all of you know these kind of schemes, but I will go fastly through it. So we have these BVOC emissions. Yeah, like isoprene, mono, and sesquiterpenes, and then a lot of gas phase oxidation happens, leading to semi-volatile organic compounds and low volatile organic compounds. And then after a lot of interactions, we are getting aerosol particles. And coming to the motivation of the study, so despite the qualitative knowledge about the connection between hydrocarbons emitted from plants and the formation of secondary organic aerosols and the underlying processes, the quantitative description is still poorly understood, and also the chemical composition is almost unknown. And another highly interesting point is the aspect of bioorganic SOA formation to its contribution to new particle formation. And the challenge here is the molecular identification of extremely low volatile organic compounds from the oxidation of BVOCs by size classified analysis. And the low concentrations of these substances, which are sufficient to interfere with particle formation, require highly sensitive and very detectable analytical methods, like, for example, ultra-trace analysis. And ultra-trace analysis is actually what we are doing in our group. So what do I do at ATTO when I go there? So I'm collecting filter samples. So I'm collecting PM2.5 at 4 different heights at ATTO with a customized half-automated approach of filter sampling at clean and polluted conditions. And we also have micro-Europhase uniform deposit impactors in A1 at 60 meters, and now also a second one at 325 meters, where we can collect particle size classified particles. And then what happens, so I take all the filters back to Mainz, where the experimental procedure happens. And so the sample preparation is quite simple. It's a simple filter extraction method, but the interesting part is the sample analysis, because here we are using ultra-high pressure liquid chromatography coupled with electrospray ionization, high-resolution mass spectrometry. And this is kind of cool because of the high mass accuracy. And we are doing a lot of mass spec in our group and also different separation techniques. And if you want to learn some more about it, you can also just scan the QR code that links you directly to our group. And if you are interested in seeing some results out of these measurements, feel free to look at my poster.
So the next poster will from Gabriela.
Hi everyone, I'm Gabriela Unfe. I'm a master's student from INPE, and I'm supervised by Dr. Luis Machado. And I'm here to talk about ozone concentration as a function of the degree of cloud electrification in the Amazon. Well, we all know, it's already consolidated that deep convective clouds through lightning are a source of ozone. However, compared to the whole cloud cover, lightning events are less frequent. On the other hand, to a certain degree, all clouds are electrically charged, which led us to the hypothesis: what if not only lightning, but also the electrification itself can produce ozone? So this is what we did in this study. And I basically used these three instruments. The first two are placed in the Campina side. So the field mu is the instrument that measures the potential gradient between the surface and the clouds and give us the electric field of the atmosphere in volts per meter. I also use the radar ring profiler, which is vertically pointed, and I use the negative vertical velocity, so the downdrafts. And located at the instant tower, I use the ozone analyzer at 2 different heights. So we have pretty interesting results. If you got interested, come see my poster. Thank you. And last but not least, Isabella Diogenes.
So hi everyone, I'm Isabella, and I'm here to show you the study that I did in my master at INPE, and it's about the variability of convective process in Central Amazon. So to understand more about these convection clouds, we try to answer some questions like how the convective behavior, seasonal and diurnal patterns of convective variability in Central Amazon. We really have 2 or 3 periods very defined along the year. And the convective systems in bigger scales can be transported and influence the formations in other convective systems in the small scales. So trying to answer these questions, we used 2 remote sensors, the satellite GO-16 and the Manaus radar, and to obtain data from some variables like cloud top, electrode charge, rain, liquid water, and the others. So this study is have an importance to understand, for example, to improve the climate models and atmospheric chemical processes. So if you want to know more about my research, see on my poster. Thank you.
So I think we are done for today, all of us. And thanks a lot for your attention, also when it is quite late and the beer is waiting outside. But I still hope for some fruitful discussions at our posters, so see you there. Thanks.